Hello and very good evening, everyone. My name is Ali, and today I will give a presentation slide about the hydrostatic pressure lab, and this is for the subject fluid mechanics 1. So let's start with introduction first. So hydrostatic pressure is the pressure exerted by a fluid at equilibrium due to the force of gravity. A fluid in this condition is known as the hydrostatic fluid. So our hydrostatic pressure lab was to determine the hydrostatic pressure of water on a flat surface. So our objectives. We have three main objectives here. First one, to determine the hydrostatic thrust acting on a plane surface immersed in water when the surface is partially submerged and full submerged. Next one is determine the experimental center of pressure, and the last one is determine the theoretical center of pressure for each of the trial performance. So let's start with the methodology and equipments. So we have three main equipments here. The F112 hydrostatic pressure apparatus, F110 hydraulic bench, and the next one is the graduated cylinder. So the procedure. First, we position the empty F112 fluation tank on the hydraulic bench. Then we adjust the screw feet until the built-in circular spirit level indicates that the tank is level in both planes. Then we position the balance arm on the knife edges and check that the arm is free to swing. Then we find the empty weight hanger in the groove at the end of the balance arm. Then we move the counterbalance weight until the balance arm is horizontal by checking that the central index mark on the beam level indicator. And we proceed. So the first part of this lab was complete by adding mass to the balancing arm with the mass hanger in 50-gram increments until the tank is full. Water was then added to the tank to the level balancing arm by increasing the force on the plane surface. In the second part of this lab, it was complete by starting with a full tank and removing mass, and the height of the water and added mass were recorded as in the first part of the lab. Now, let's talk about the results. From the data collected, the hydrostatic pressure and the distance to the center of pressure can be calculated for both the partial submerged and full submerged plane surface. Once this is done, the theoretical hydrostatic pressure and the distance to the center of pressure can be calculated. From this one, could compare the theoretical values to the actual values measured. The percent difference is then determined. The percent difference between the measured and the theoretical value forces was almost nearly zero for all increments. We did have some discrepancy between the measured and theoretical depths to the center of pressure. The percent error of depths to the center of pressure ranged from 1.97% to 50.427%. Following is the graphs for the hydrostatic pressure and the distance to the center of pressure for partially and fully submerged. So this was the hydrostatic force with versus average force graph for fully and partial submerged. This one is the distance to center of pressure versus average depth to graph for partially and fully submerged. And the last one is the measured distance to center of pressure versus the theoretical distance to the pressure for partially and fully submerged. Now, let's talk about a big discussion. So, the force applied in the system of vertical face of buoyant material counteracts the mass added to the hanging arm. So we know that if we move away from the sea level, the pressure will change either with air or water. So in our experiment, also change in pressure because of the weight of the water above and the buoyant forces clearly show the properties of water. The water pressure was so high that we add the mass of 50 gram to 450 gram even still quadrant was able to support it in static equilibrium. So the idea led us to believe that the curved area allows for a larger surface with which the water can act upon for less change in depth. This would explain such a large jump in force applied after breaking the upper plane of the vertical face. For conclusion, the graphical analysis of our lab showed that the linear relation between hydrostatic force and the average depth for the partial submerged and the graph of hydrostatic force and average depth for full submerged is also linear. Our theoretical force compared to the measured force were nearly identical with a percent of error 2 to 14%. The error in the distance to the center of pressure compared to the theoretical was outrageously high with a percent error of 50%. The graphic analysis showed a linear relation between hydrostatic force and average depth for only fully submerged. The graph of hydrostatic force and average depth for partial submerged is not perfectly linear. And that's all for this lab experiment. Thank you so much for your attention and have a good day.